Trains of 40 vehicles or more are a common sight in the USA. Now Britain too has the super train, ironically made possible by means of an American locomotive designed and built by General Motors. This is the story of 4 such locomotives, owned by construction materials supplier ARC Limited. Mineral working has been going on in and around the Mendip Hills since before Roman times, providing vital raw materials to shape the environment. ARC's rail operation is based at Watley Quarry in Somerset, some 4 miles west of Frome. The quarry has been worked since 1937, when a narrow-gauge railway was laid to carry stone to the processing plant at an earlier quarry just over 2 miles away at Hapsford. The 2-foot gauge line fanned out to the rock faces where the freshly blasted stone was loaded by hand. In 1943 it was converted to standard gauge, thus providing a direct link with the GWR Radstock branch. Due to the restricted loading gauge and tight curvature of the quarry line, the standard gauge trains were still marshalled at Hapsford, the wagons being moved to and from the loading point by 4 company-owned Sentinel steam engines, which were specially designed to negotiate the tight curves. Sentinel No. 3 still survives in a local children's playground, the steam fleet having been finally displaced in 1968 by 4 Thomas Hill diesels, the last of which is still in use. The next development came in 1974, when, to eliminate the worst of the tight curves, the old track bed was partially abandoned in favour of a new deviation. This enabled BR locos to reach Watley for the first time. As well as a bridge, the new route required 2 new tunnels. Modern exchange sidings were also provided just outside the quarry at Watley Bottom. In the mid-1980s, ARC opted to concentrate its operations in the East Mendips on the environmentally preferred rail-connected Watley Quarry, while suspending its operations at 4 road-served quarries. As part of the redevelopment, over £24 million was invested in rail distribution, bringing the facilities up to their current state. In addition to carrying out further track improvements and installing rapid loading equipment, ARC acquired a new shunting locomotive, a fleet of the latest low-track force hopper wagons, and of course the 4 Class 59 locomotives. Her Royal Highness the Princess Royal officially opened the initial phases of the redevelopment that has now cost £50 million to date in October 1987. On the opposite side of the public road from the quarry, a modern rail depot was also established. The manager is Steve Cole.
The rail unit is a separate operation altogether to the quarrying activities at Watley. We employ something like 27 men. 7 men are on the maintenance programme with 2 supervisors. They deal entirely with the maintenance of the mainline locomotives and the 2 shunters. The wagon maintenance is undertaken by our contractors Marcroft Engineering, who are responsible for our own 145 privately owned wagons and the 126 hired wagons that we've got on site at the present time. They ensure the fleet is maintained to full British Rail standards. The track maintenance is carried out by 2 individuals walking and maintaining the 3 miles of track to British Rail standards, and we have 3 teams of 4 men working 24 hours a day on the 2 shunting locomotives, marshalling and moving vehicles. In addition to this, the unit is administered by a staff of 4, who among their duties are responsible for the day-to-day dealing with British Rail, both at Westbury and Islington, for the organisation and planning of our trains.
Rock blasting takes place most weekdays and is preceded by a lengthy warning siren. The freshly blasted limestone is then loaded into Caterpillar dump trucks, each as high as a double-deck bus, and fitted with a special suspended rubber body to cut down noise. Over 85 tons of stone is brought to the crushing house on every trip. Inside, there is one primary and two secondary crushers. To give an idea of scale, the impact rotor of the primary crusher alone weighs over 43 tons. The stone is then sorted or screened into a range of different sizes and blends suitable for various constructional uses. From the screen house storage bins and the ground stockpiles, the products are drawn off and carried by conveyor to the travelling rail loader, which can handle up to 2,500 metric tons per hour. The equipment can traverse the full length of the 4 loading sidings, each of which can accommodate trains of up to 2,000 tons capacity. Overseeing the operation is the first floor control room. A sophisticated computer keeps track of the loading process, itemizing each and every wagon. Rail movements at the quarry end are normally carried out by one of the 2 diesel shunters, the main one being Pride of Watley, a 75-ton Steelman Royale built by Thomas Hill in 1987 and fitted with a 750 horsepower Caterpillar engine. The wagons traverse a computer-controlled weighbridge, the information being fed back to the first floor control room. Beyond the road bridge, the wagons are marshalled in the new exchange sidings, normally the mainline loco's closest point to the quarry itself, although when necessity demands, Class 59s are also occasionally used to carry out shunting movements. The initials ARC originally stood for the Amalgamated and latterly AMY Roadstone Corporation, but now the company is simply ARC Limited. Steve Cole explained why the company decided to employ its own mainline motive power.
The redevelopment of Watley Quarry was being planned in the early 1980s to meet the increasing demand for aggregates in southeast England. The company had to look at a reliable way of meeting this market, and a number of options were looked at. The British Rail Class 56 locomotive, which had been a workhorse in the industry for a number of years, had proved limited to 2,000-ton payload. Although attempts at double heading were tried, these were eventually considered unsuccessful. The other options looked at were the brush locomotive built at Loughborough and the General Motors Class 59 locomotive, at that time built in Chicago. Cooperation in the industry extended to such a point that Foster Yeomans allowed us to use one of their locomotives for proving trials, which in the end provided the information which convinced the company that the General Motors option was the most favourable.
Foster Yeoman had already taken delivery of the first of a fleet of 4, later to become 5, Class 59 locos designated 59-0. ARC's order for 4 Class 59s was submitted in 1989. The locomotives were built in Canada at General Motors Diesel Division in London, Ontario. Pictures taken on the assembly line show the various component parts of the locomotives, all of which are standard GM product. This is the rear end of the number 1 bogie, showing one of the traction motors slung between the wheels. Closest to the camera are the 2 sandboxes. Here's the underframe before being turned upright. It shows the 2 main air reservoirs, the battery boxes, and of course the main fuel tank. This will become the clean air compartment when the body shroud is fitted. To the left is the main generator and the shaft driving through to the air compressor. In front of that is the hydraulic parking brake unit. This is the actual 645E3C diesel engine installed in 59101. This is the equipment rack with the water header tank. Here the rack is seen installed on the right of the picture. The header tank is on the top, with the lube oil filter tank on the bottom right, and the lube oil cooler in between on the angle. And this is the air compressor. The locomotives were built to an impressive specification. The heart of the Class 59-1 is a turbocharged 16-cylinder 2-stroke diesel engine. The main generator has a maximum continuous rating of 7,020 amps. All 4 locos were shipped to the UK aboard the jumbo line MV Stella Mare, a Dutch-registered vessel. They were offloaded at Newport Docks on the 20th of October 1990. Unveiled for the first time on home shores, the magnificent colour scheme that suits the locos well. The following day, the locos arrived at Watley behind Class 56-040 and were soon settled into their newly constructed home. After successfully completing a series of routine commissioning trials, ARC's new workhorses went into commercial service on the 5th of November. But have they lived up to expectations?
Yes, indeed. The locomotives were ordered with a requirement for 95% availability, and we've actually exceeded that in the first months of operation with 98.2% availability. Furthermore, the reliability of the locomotives has been excellent since the day they entered traffic, with very few problems out on the track, which means that we can deliver our product to the depots with guaranteed reliability.
Has the fact that the loco's manufacturing base is several thousand miles away caused much of a problem getting spares and backup?
Not at all. General Motors already support 40,000 locomotives in 62 countries of the world, and the challenge to meet our demands here in the UK has not presented any problems at all to us.
Every time the locomotives return to Watley, which could be once or twice a day, they receive a turnaround examination. The fuel tank is filled to capacity, a maximum of 1,000 gallons or 4,550 litres. The sandboxes are checked and topped up as necessary. The driver's repair book is checked to see if any defects have been reported. Inside the engine compartment, the engine lube oil is checked. As is the water level. At ground level, the running gear is examined, the axle boxes being checked for any signs of overheating, etc. The brake blocks are checked for wear, and the brake gear to make sure it's all secure. In the cab, checks are made on the operation of the windscreen wipers and washers, the headlights, marker lights, and cab lights. The fault annunciator reveals whether any problems have been detected during operation. Once the locomotive is finished inside the workshop, it's taken outside, where the high visibility panel, windscreens and cab windows are all washed. It's 11 o'clock on a winter's evening, and Pride of Watley passes the shed with the empties off the 1756 from Dagenham. 59103 is due back on shed as 104 prepares to take the 0015 return. The maintenance depot provides almost round-the-clock cover. The locos arrive for routine servicing at any time during the day or night. To accommodate this, normally 2 shifts operate from 6 o'clock in the morning until 1 o'clock the following morning, starting on Sunday night and continuing right through to Friday night. Every 4 to 5 weeks, each loco also undergoes a comprehensive B exam and service. Each exam specifies a schedule for items which only require 3 monthly or 6 monthly maintenance, ranging from B1 to B12. Between them, the exams cover all general maintenance required for a full year's operation. Here, 59102 is undergoing its B6 exam. This includes checking clearances of the lash adjusters on the valve gear and the fuel injector timing, etc. From beneath the loco, the electric motor armatures and carbon brushes are inspected. A full inspection of the airbox, where the air is blown into the inlet ports from the turbocharger, reveals the actual pistons. The crankshaft is slowly turned so that the cylinder liners, piston rings and skirts can be checked for any signs of wear.
Okay, that's 9 thou. And the grooves were fine.
The 4 locos have been named after local villages. The first naming was of 59103, Village of Mells, at Old Oak Common Open Day on the 18th of August 1991. It was named by John Bates, director of BR Trainload Construction. Next, 2 locos were named during the same weekend. On Saturday, number 104 became Village of Great Elm at Network Southeast Gala Day at Cambridge. The ceremony was performed by ARC Southern's Operations Director, Terry Last. On the following day, 59102 was named Village of Chantry at Lara Depot Open Day, with General Motors Export Service Engineer Paul Moy doing the honours. Finally, in the rain at Bridge North at the Severn Valley Railway's Diesel Gala, ARC Southern's Managing Director Andrew Dougal named 101 Village of Watley. In order to get an idea of the driver's working environment, Jerry Beasley showed us around one of the cabs of Village of Mells.
This is the number 1 end, and the first thing you will notice is the driver's control stand. On the control stand we have the radio which communicates with the British Rail National Radio Network. Below that is the power control handle for the throttle, and underneath the reverser key. On the overhead panel, the driver has switches for cab lights, desk lights, instrument lights and the demister. There is a rotary switch for the headlights and marker lights, and another switch for the tail lights and the brake control isolation. There is also a power supply socket for 74 volt DC. To the driver's left we have the AWS reset button, a manual sanding control lever which can be used when the locomotive is running below 5 miles an hour, the automatic air brake lever which controls the train brake, the direct brake lever which is used purely for locomotive brakes when making light engine movements, the driver's horn valve control, the emergency brake button, and a sanding isolation switch which is used to cut out sanding when running light engine. These gauges here, the one on the left shows main reservoir pressure and the main reservoir pipe pressure. The main reservoir pipe is the yellow hose that connects to charge the air system on the whole train. The next gauge shows the bogie brake pressures on each of the 2 bogies of the locomotive. Above that we have the buttons for controlling the parking brake on and off with an indicator showing the parking brake condition. There is also a button for the brake overcharge control. The brake pipe control gauge shows 2 needles, one which is the setup or control pressure for the brake pipe. The second needle in the middle of the gauge reads the actual brake pipe pressure. The outside one shows the pressure the driver requires to achieve, and the inside one shows the pressure that is actually in the brake pipe. Above it we have warning lights for the brakes, AWS and engine, which show normal condition yellow and fault condition red. If I stop the engine, this light will turn from yellow to red. And here we have the wheel slip and general fault indicator lights. Between the brake pipe gauge and the speedometer we have the automatic warning system indicator. Here is the speedometer. The current maximum permissible speed for these locomotives is 60 miles an hour. There is a dimmer switch for the instrument lights, beneath which can be found the windscreen wash and wipe switch for the driver's windscreen. There are 3 buttons for engine starting and stopping. The first is for priming the engine fuel system, second for starting the engine, and the third for stopping the engine. Above these buttons we have an ammeter which measures traction current. There is also a fire alarm test button. This far panel includes a button for the crew communication buzzer to the second cab. There is an emergency shutdown button in case of fire, which will also trigger the fire fighting system. There are controls for the driver's hot plate and for the second windscreen wash and wipe system. We mustn't forget driver's comfort, and here we can see the driver's cab heater. On the second man side there are just 2 controls, the driver's safety device reset button and a horn lever. The blue cap is where the windscreen washer bottle is refilled. A vigilance control is fitted. The driver must recycle the pedal when he gets an audible warning, which is about every 60 seconds. If he fails to do this, the brakes will automatically be applied. This is the module control cabinet for the locomotive. It contains the various electronic modules which control the locomotive, including wheel slip detection, etc. It also contains various diagnostic tests. As an example, it's possible to operate the radar test switch to get a reading on the speedometer. This shows us that the speedometer functions correctly.
"59102 emerges from the 2-road loco shed in readiness to haul the 0830 to Theale. To get hands-on experience where it really counts, out on the road, we shall be riding aboard as far as Westbury. In a typical week, ARC's 4 Class 59s haul trains to a network of distribution depots throughout the southeast of England. Destinations range from Wolverton in the north, Allington in the east, and Fareham in the south. The trains are usually formed from 2 main types of wagons, the older box wagons, known as JUAs, and the LTF low track force wagons, known to BR as type JHAs. There are still some older PGA 4-wheel hoppers in use as well. The 0830 to Theale is one of the heaviest to regularly leave the quarry, consisting of 40 LTFs, making a total payload of 3,180 metric tons. The wagons have been assembled by Pride of Watley, but before it can venture onto the main line, a number of strict procedures have to be carried out. Firstly, the whole train is inspected by the RST, or Rolling Stock Technician. A BR employee, it's his job to look at each wagon individually to ensure its mechanical integrity. Approximately halfway down the exchange sidings, adjacent to the chargeman's cabin, the loco reverses from the reception road to couple to its train standing on the departure road. Accompanying us will be ARC's rail traffic controller, Robin Jacob. Rob met up with BR Traction Inspector Chris Crompton and driver Clive Byrne before boarding 59102, village of Chantry. Once the Class 59 is coupled up, the driver carries out a mandatory brake test in conjunction with the resident BR chargeman. To guarantee the continuity of the brake, all the air is evacuated from the pipe by means of the valve on the last vehicle. Bearing in mind the train has been assembled from 2 portions, the driver, seeing his gauge fall at the opposite end, knows that the train is now complete. The chargeman will also check the calipers on individual wagons before reporting back to the driver.
Thank you, David.
What exactly are the chargeman handed live now, Chris?
Well, that is the loads list for the train in hand. Now, it's
Clive has already checked that earlier on before he got on the loco to make sure that it complied with the table E in the working manual for rail staff to see that you had the correct load and the train wasn't overloaded and the brake force was that as required for the train. As you can see, Clive's now been told by Dave, the chargeman, that he's allowed to move, releasing the brakes. And with the weight of this train, the train will move forward very gently under its own momentum.
At this slower speed, it gives us a chance to see our exchange sidings on the lower half of the Watley reception area.
As you can see, Robin, we've slowed down considerably now, because what the driver is going to be making sure is that he's got good control of the train, so that as he comes around the corner, which we can't see at the moment, but there's a signal just around the corner there, which is the outlet signal from the quarry. And he wants to make sure that he approaches this with caution in case the signal is at danger. He has been given permission by the chargeman to leave the quarry, and he has also been told that the signal should be clear. However, a cautious and good driver will make sure that the signal is clear. And it's just coming into view now. Yes, and he's got a clear signal, so we now can proceed out of the quarry towards Westbury.
Clive's not touched the throttle at all at this stage, and Chris at all.
No, there's no need. You're on quite a sharp falling gradient.
Purely momentum of the loaded train carrying us forward at this stage.
Momentum of the loaded train will push the train out of the quarry quite quickly. And because of the curvature of the line, we don't want to exceed the maximum speed of 20 miles per hour.
We are just going through the first tunnel on the branch line. This is the unfortunately named Mendip tunnel. It's 55 yards in length. This bit of the track was realigned in 1963 to make movements in the quarry easier. And you can just see slight alignments of the old branch here on the right hand side.
As you can see on the speedo there, the driver's keeping control of the train down to 20 miles per hour. He's also got the brake on, because at the moment we're going down a 1 in 140 gradient, and he doesn't want to exceed the maximum speed at all. But there's the AWS ramp for the ingoing signal, which we passed just now.
I take it, Chris, the signalling into Watley is all under the control of the Westbury power box, is that correct?
Yes, it's all controlled by Westbury. The incoming and outgoing signals from the quarry are controlled from Westbury panel box, some 14 miles away. The BR signalman will not allow a train to enter the quarry unless he's got permission of the chargeman. And the chargeman will not allow any shunting movements to proceed past the signal until he's had the permission from Westbury panel box.
We're just going over a slightly new alignment we've carried out in the last 12 months, realigning the bit of track here to negotiate the river at a better angle and avoid a bit of an S-bend in the track. I believe the Westbury driver is a lot happier with it now.
Yeah, the drivers are feeling a lot better because the track's a little bit better for them to travel over, and it makes for a smoother ride, and there's less flange wear and wear on the tyres.
And you can just see on the left-hand side now, Chris, the alignment of the old branch line, which was severed back in '74 to make this new alignment. Now just going into the Great Elm Tunnel. We're now approaching Bedlam Tunnel by going over the new overbridge, which carries us over the old alignment, and just entering Bedlam Tunnel now, a 245-yard tunnel, built on a cut and cover basis, slightly curving to the right-hand side.
Clive has now opened the throttle for the locomotive to bring us out of Bedlam Tunnel up the slight gradient towards Hapsford ground frame. Hapsford ground frame is controlled from Westbury panel signal box. The line coming in on the left hand side is heading off towards Radstock, where there was some wagon repair shops. It used to be the old main line between Bristol and Frome many years ago.
And, here on the right we have the old alignment, if you can just about make it out, the old loop serving the Hapsford exchange sidings. Hapsford exchange sidings were used by the company up until around about 1974 when the new alignment was put in.
Clive now should be still powering up to bring the train out of the quarry. At the moment we're doing approximately 15 mile an hour, 10 to 15 mile an hour, and he's using the throttle to control the speed of the train so as it won't exceed the 20 mile an hour that we've just come through. As soon as the speed of the train is risen, he'll be starting to bring the throttle back so as to keep the train under close control. The majority of the train is now on the falling gradient, and the driver's out of shut off to ensure that he doesn't exceed the 20 mile per hour.
So again, it's just the momentum of the train carrying us forward at this
The
stage.
full 4,500 tonne of the train pushing us down.
We're just passing the site of the old Hapsford marshalling exchange siding on the right hand side.
We've just come through the dip there, and the driver will be powering up to maintain the speed of the train over this climb towards Spring Gardens and Frome. With the older type stock with instanter or screw couplings, the driver would have had to ensure that he kept the couplings taut so as not to cause a snatch. With the modern Buckeye stock, there's no problem at all. Clive will be now increasing power to maintain the speed of the train. It's quite a steep gradient out of the bottom of the dip there, and he'll be applying nearly full power to bring the train out over the top here at Spring Gardens. Again, he's got to keep careful control of it because he doesn't want to exceed the maximum speed of the line, and because it drops down a little bit towards Frome now, so he doesn't want the speed to increase too much when he gets into the dip.
Presumably we're descending all the time into the Froome area from this point.
Yes, I believe that is correct.
Will the yellow aspect cause us a problem?
We're approaching to Westbury 291 R, which is the distance signal for Westbury 291 signal at Spring Gardens. It shouldn't cause a problem. The rail conditions are dry today. The sandboxes are full, and I shouldn't think we'd have a problem in pulling the train away from what is quite a steep starting point on the branch line.
So we should have no trouble getting away with
Shouldn't
4,000
have much
tons
trouble.
from the signal.
We're just passing milepost number 1, which is measured from Froome North Junction, and we're just about to pass over the AWS ramp for the signal here at Spring Gardens at Froome. The driver's approaching this signal very cautiously, so as not to risk the danger of passing the signal at danger, which is a serious disciplinary offence on British Rail.
It's obviously where machine and driver technique will come into their own at this stage, and Chris
This is where
the
the skill of the driver is very highly regarded. To stop a train of this size and weight in the correct position takes a high degree of machine understanding and driver's route knowledge and skill.
Hello, officer. 6A42, ready to go at 291. Righto, thank you.
Stopping here at Westbury 291, if the signal doesn't clear within 2 minutes, the driver has to carry out the rule book instructions, which means that he gets on the phone and reminds the signal of the presence of the train. And as you can see, the signal has now cleared.
The officer said that he's got a fast up later, so we may have to go up the reception and not the main line.
This is at Froome.
That's at Froome Club, is it?
Froome
At
North.
Westbury,
At Westbury.
put into
Okay.
Westbury. We've got the up reception and not the main line.
Okay.
What would be the procedure at this stage, Chris, starting the train on this sort of
he's
gradient?
made sure that the brakes are fully released. He's released the direct locomotive brake, and he's gently powering the locomotive up to feed the power down onto the traction motors. The driver has now applied virtually full power down to the traction motors, and that high-pitched squeal or whistle that you can hear is the Super Series cutting in to ensure that the maximum amount of adhesion is applied to the road wheels. This will ensure that for a heavy train like this, the single locomotive will pull the train from a heavy gradient.
Just passing here on the left-hand side, the site of the old Froome Gasworks, which was once rail connected many years ago.
The driver has been slowly increasing the power. The idea behind it is that if you were to apply full power from a standstill, you could cause all sorts of problems and possibly burn out the wiring to the traction motors. So as the speed of the train moves away, then the driver will slowly feed in more and more power.
Speed increasing now to what's somewhere around 5 miles an hour at this stage?
We're just under 5 miles an hour now, and the driver is in notch 6 at the moment. We've got about 7,000 amps on the gauge.
Amperage dropping back now quite considerably, so they obviously getting a good grip of the trailing load at this stage.
See, it's had no great difficulty. It's accelerating the 4,100 ton from a standstill on what is quite a heavy gradient. And it's finding no problem with it at all.
Just coming out to just under 10 miles an hour now then, so obviously no apparent problems with today's rail conditions.
No. With a dry rail, you should never have any problem moving away from Spring Gardens. Notch 7 has now been selected, and the amperage has crept up to just under 6.5, dropping back again down to about 6,000 amps.
Speed remaining fairly steady at this stage at 10 miles an hour then.
Well, the loco will find its own level as to what it feels happy with producing, and which will be approximately 15 miles an hour. It'll find its own level and speed. We are on quite a heavy gradient pulling away from this part of the line.
The approach to Froome West now and the curvature up Froome North causes any problems with that little bit of gradient there as well?
Yes, you'll find the speed will drop down because as the train goes into the curve, it'll knock some speed out of the train. But we've got plenty of power in hand to be able to pull away from that with no problems whatsoever. You'll find the speed will drop down just a fraction, and the power should increase slightly.
Obviously kind of squealing off the flanges, so the reasonably tight curvature up around this section of line.
The squeals you hear are off the flanges. The Super Series hasn't decided that it is required at the moment.
Still maintaining quite a good speed here at just under 20 miles an hour then.
Yeah. We just passed Westbury 295 signal at Froome North Junction, and we are going on the up Froome line. The line on our left is the loop line which can allow trains from Watley Quarry to take a different route at Froome North to allow other trains to pass them. The line coming in on the right hand side is the down Froome line. Both these lines are bi-directional, which means they can be used by trains in either direction. The gradient from Froome North up to Clink Road Junction is 1 in 264. which gives the locomotives quite a bit of work to do, pulling heavy trains out from North Junction.
Clink Road Junction presumably being the junction with the West of England main line, Westbury to Taunton.
Yeah, that's correct. The Westbury to Taunton line bypasses through. The avoiding line, as it's called, was built around about 1930s, and this was the original main line from Westbury to Taunton, built in the late part of the 1890s, all up to around about 1905.
Marker board on the left-hand side, Chris. What exactly does that indicate?
That's an emergency warning indicator. Just round the corner we'll see a temporary speed restriction board, and that will warn the driver that up ahead there's been a need to put a restriction on the line because of a track or bridge defect, which, whilst it's being worked on to bring the line speed back up to maximum line speed, it will mean that all trains will be restricted over that bridge until the repairs are carried out.
We're just going past the restriction for the miles per hour maximum, presumably.
Yeah, that showed us a 30 over 60. 30 mile an hour applies to all of the trains. The 60 mile an hour applies to passenger, parcels, postal trains, and trains consisting of sprinters and light locomotives.
Just approaching Clink Road Junction now. What would the normal line speed be on this junction, Chris? Bearing in mind we have a current engineer's occupational speed on it.
The normal speed for a train coming out of Frome would be 40 mile an hour through the junction, but the line speed, as you can see, is 100 miles per hour on the main line. We've now joined the main line at Clink, 114.5 milepost. Still in maximum power, and with the majority of the train coming around the junction, the traction effort has had to increase up to approximately 6,000 amps to bring the train onto the main line.
Are we still climbing at this stage, Chris? Or?
No, we're dropping down from Clink down towards Fairwood Junction at Westbury. We're passing now the site of the temporary speed restriction, and up ahead we can see the bridge for the new Frome bypass, which has been built just recently.
So we have a clear run now into Westbury with the green aspect coming out.
Well, that indicates that the next signal will be showing a proceed aspect. We will not see the junction signals for Fairwood until we get a little bit further on around the corner. We're still going quite slowly because the rear of the train is still on the speed restriction. With a long train like this, we'd have cleared the junction just as we approach this signal. But because of the 30 mile an hour temporary speed restriction, the driver must still maintain a close watch over the speed of the train so that the rear of the train doesn't exceed that speed restriction.
Yes, we had a slight joke then, Chris. Could you explain the reason behind that one?
The 59 is wired that your main alternator is split into two parts, and for starting you need the greater power and a greater tractive effort. So what we will do, it will maintain the specific way of wiring it. And then at 25 mile an hour, it doesn't need so much power. It needs more maximum speed then. It doesn't need the starting power. So what it will do, it will change the wiring in the main alternator to provide a more constant power output throughout the speed of the locomotive.
Approaching flashing double yellow, Chris. Could you explain the workings of the signal, please?
It is a preliminary caution to inform the driver he's approaching the junction where the route has been set. It is an additional aspect to the normal signalling and is fit to certain higher speed junctions. You'll expect to see the next signal to be displaying a single flashing yellow. That will then tell him that the next signal, which is the one at the junction, will be displaying a single yellow with the junction indicator number 1 to take you into Westbury.
Presumably we're still on a falling gradient at this stage, Chris. Are we approaching Westbury?
Yeah, approaching Fairwood Junction, this gradient is downhill, approximately 1 in 220. And the driver will be throttling back now to ensure he doesn't exceed the 40 mile an hour speed restriction through Fairwood Junction. And there's the warning board for the 40 mile an hour speed restriction for Fairwood Junction. As you can see, the signal up ahead is the signal for Fairwood Junction, displaying number 1 route indicator, which tells the driver that his route is set through Fairwood Junction towards Westbury. The line off towards the right is the line towards London, bypassing Westbury.
So we're now faced with a double yellow. What would that tell Clive at this stage?
It would tell Clive that he has got the route set towards Westbury and that his next signal should be a single yellow. However, now that the signal is cleared to a green aspect, it's telling him that the next signal should be showing a proceed aspect, either another green or a double yellow.
Yeah, so that we're clear all the way now through to Westbury then, Chris, in fact.
Yes, well, the signals have now told the driver that the route is set in towards Westbury, and even though the speed for the junction is 40 miles per hour, Clive's been slowing the train down to approximately 20 miles per hour because of a permanent speed restriction on an underbridge just past Fairwood Junction here. The heavy axle weight of the vehicles means that certain underbridges are getting damaged by the weight of the axles travelling across them. So by reducing the speed of the heavy axle vehicles across them will mean that the damage that is caused is considerably reduced.
The track on the the right-hand side here, that is the Westbury voiding line to the effectively the West of England to London line.
Yeah, that's the Westbury voiding line. It goes from Fairwood up to Haywood Junction, built around about the same time as the Frome voiding line, to allow fast trains and fast expresses to the West Country to bypass both Frome and Westbury.
signal we're approaching now, Chris, with indicator board on top of, if that was illuminated, what would that mean to Clive from the driver's point of view?
Clive would take that to mean that he was going off to the right on the reversible signalled line, which is the down Westbury. As you can see, the junction signal up ahead is on gantry. If he had that signal off to the right, he'd go across onto the down Westbury there and stop at the right hand signal there.
Junction we're approaching now, Chris, what's that defined as?
This Westbury South, you have lines coming in from Southampton, and you have trains coming from the London at Westbury North, or from Trowbridge at Westbury North. They can take the route either to Southampton or down towards London on the down Westbury there.
A little bit of a gradient here on the approach to the station.
From that last signal, you are climbing into Westbury, and on a wet morning, or during November, autumn time, when there is quite a bit of rail debris and mush on the track, it could prove quite an interesting climb out.
It's problematic.
Not on a day like today.
In the down yard there are some slightly ageing 51-ton PGA hoppers waiting to go down to Watley for reloading.
Yes, and in the upyard is a train of 102-ton yeoman's vehicles with the Class 59-0 on the front. We're arriving at platform 3 here at Westbury. Westbury can still be quite a busy little junction with freight and passenger traffic heading in all sorts of directions, such as Cardiff and Bristol, towards Reading and London, down towards Salisbury, Portsmouth and Brighton, and of course down to Exeter, Plymouth and Penzance.
Clive will be relieved at Westbury. Do all the drivers take relief at Westbury, Chris?
Yes, because of the distances involved, it is very difficult to schedule a driver through to a terminal and back again due to the time factor.
So we normally on our services have drivers working from Watley to Westbury on a shuttle type basis, and then obtaining relief at Westbury for onward movement and back from the depot.
Yes, the time factor is the defeating object. Class 6 and Class 7 freight trains do not take the priority on the line.
Well, thanks for the trip up, Chris. I'm afraid I'm going to have to take my relief here as well today.
Thank you for a very enjoyable trip, Robin.
Following the change of driver at Westbury, our train continued towards Theale, a further distance of 44 miles, the first 2 miles of which we shall see as we head towards the main line. Just off to the right is Westbury Panel Signal Box. This is Westbury North Junction, where the regional railways route diverges towards Trowbridge, Bradford-upon-Avon, Bath and Bristol. The crossover allows access to the reversible platforms. In the background, the embankment of the Westbury avoiding line shows its close proximity to the station. Converging from the left is the third side of a triangle connecting with the Trowbridge line at Hawkridge Junction. This is known as Westbury East Chord. The avoiding line converges at Haywood Junction. We're now on the Berks and Hants, the West of England main line from Taunton to Reading, with a maximum line speed of 110 miles an hour. The line to our left is to the Blue Circle Cement Works, which still sees regular usage. A Class 08 shunter can be glimpsed in the reception sidings. This is where Westbury Panel hands over control to Reading. And so to Theale, lying roughly halfway between Aldermaston and Reading. Both ARC and Foster Yeoman have distribution depots here. Blue Circle has a cement terminal as well. Diverging onto the up loop at Theale, the train then joins number 1 reception line adjacent to milepost 42. We now enter number 2 reception siding, the line joining from the left being from the unloading shed. Here you can see the two adjacent unloading sheds, Foster Yeomans in red and ARCs in grey. The signal to the left is the Foster Yeoman shunt signal, the extremity for the 59 Zeros. As the ARC terminal is slightly further east, the 59 ones have to pull right up alongside Theale station. The shunters talk to the driver by means of walkie-talkies. Once permission is given, the train sets back through the unloading shed into the first siding where the train is divided. The second half is then propelled into an adjacent siding. Now the process of unloading begins. With the benefit of the depot's rapid discharge installation, this takes between 2 and 3 hours. The wagons are hauled back through the shed by the Class 59, their payload being released one by one into a hopper below the track. From here, the stone is moved by conveyor to the stock bays and thence loaded into lorries for the final part of its journey to local building and construction sites. The Class 59 not only plays a vital role in helping to shape our environment, but also brings with it major environmental benefits of its own. For every 4,000-ton train dispatched from Watley, around 200 lorries are removed from our congested roads.